Okay, so today we will solve some more questions so that it will make you understand that uh, this particular AC analysis is nothing but what we had done earlier, but some small changes which now I think you are comfortable with, that how to make these changes and solve the questions. So in line with this, let us say you have this question, that is find the equivalent of the circuit shown below if omega is 4 radians per second. So if I am saying find the equivalent of the circuit shown below, so can you tell me what I am asking you here? Like, can anyone tell me?
Yes, sir. Sorry, impedance to that.
Sorry?
Impedance.
Sort of, but basically, if I'm asking you to find the equivalent, then you immediately it should come to your mind that something related to, a Thevenin or a Norton. So something like that. You understand? We will write that specifically. Sorry, can you tell again what you are saying?
So these specialties are telling find equivalent, so we can use Norton or Thevenin in any of them.
Yeah. Until unless we tell you to do it through Thevenin or Norton, that is a different thing. Okay.
Okay.
So now we have to find the equivalent circuit shown below, which I will be drawing now, and we have to determine the voltage VLT. Determine VLT when 1.2 ohms resistor is connected across the terminal. So we will check what that is. So let us say you have this circuit here, plus minus, then you have 0.25 ICT, capacitor, like this. So basically what we are asking you is to find the equivalent of this circuit looking from here. So basically what we are asking you is to find V Thevenin and R Thevenin for this circuit looking from this terminal, so A and B. And the second question is, once you are done with calculating the V Thevenin and R Thevenin looking into this terminal, then what they are asking is to calculate the VLT. To calculate the VLT, if you connect a load resistance like this. So this is the 1.2 ohm resistance, and what we are asking is to calculate the voltage across this. So just a minute. So I will remove this from here. So what they are asking is to calculate the VLT across 1.2 ohm resistance, and initially it is not connected. So it is not connected initially. It is so it's open here across the terminals A and B. So first of all you have to find the V Thevenin and R Thevenin, and then you connect the resistance using this V Thevenin and R Thevenin, and then find out the voltage across this 1.2 ohm resistance. So, and the current source here is cos 4t. Any doubts here related to this question? This is 0.25 Henry.
Sir, which is the IC?
Sorry? Oh, okay. Yeah. Good. Just a second. So this is not 0.25, this is actually 0.5. And ICT is this. This is ICT. So first of all, you tell me what is the VTH for this circuit, which is given over here. So before going, what is the step that we have to follow first before doing all that calculations? Can anyone tell me what will be the step?
You have to VTech
No, no, that is okay. That is for RTH.
Converting into frequency.
Yes, yes, good. So that is the first step. So you do it like that, convert this into a frequency domain version of this circuit, which is a time domain right now, and then solve for different currents. And you all know that all these ICTs will then become a module, a bold letter IC. So I hope you know now these things. So I'll give you 10 minutes to solve this because this requires some calculations. So right now it is 10:30. So at 10:40 I will ask you the results. Or in case if you can find out in between, you can tell me the answer.
Sir, what is the current source? Can you repeat the value of it?
Current source value is cos 4t.
Okay.
सर यहाँ पे VTH और RTH भी करना है फाइन
हाँ VTH करना है पहले, फिर RTH you have to do it, and then you have to find that equivalent, right? So that equivalent will be VTH in series with RTH, and then once you find that out, you have to connect this load resistor across it, and then find the voltage.
सर VTH माइनस जे आ रहा है
VTH is what you are saying is minus J. Just a second. No, it's not minus J.
RTH would be minus J.
No, RTH is also not minus J. Yes, students, anyone? It's a very simple question, I guess. So once I'll solve it, then you will realize it actually. So
VTH
VTH is how much?
J
No, it's not J.
Sir, is RTH 0?
No, not 0. RTH is not 0.
सर RTH is equal to minus 0.047 J
No, it's not that.
Sir, VTH is 4 by 5 plus J 4 by 10.
Can you express that in polar format?
सर
Yes.
सर is it 0.89 angle minus 63.44
Right. Good, very good. So this is the answer actually. 0.894. Is this the same student who was giving me the polar Cartesian representation, or is it a different one?
No sir different
Okay. What's the name?
Viren
Okay. Good, Vinay. So actually
Thank you.
answer is 0.894 angle minus 63.43. So let me solve this so that everyone will understand how we have to solve these type of questions. And remember one thing, here we are not doing anything special. So if you remember, I was telling you whatever Thevenin and whatever theorems we have studied last time, we have to apply same logic here in these type of circuits also. Nothing extra is to be learned from here, apart from subtle changes which I have already discussed in our earlier lectures so many times. So let me copy this circuit once again, and as I was telling you, the first step is to convert these things into the frequency domain counterpart. So if we want to do that, then just a second. So this will be what? This will be 1 angle 0 or not? This one. Everyone will agree with this?
yes sir
So this is 1 angle 0. Okay. And how about this? What will be the answer for this?
J
J omega L, right? And
answer J
so answer will be 1 J, right?
yeah J yes
Okay, so we'll keep it as J. How about this C?
minus 0.5 minus J by 2
Minus 0.5.
J
Okay. So everyone is okay with this, like how we got this? This is nothing but 1 by j omega c, and omega you know already and c you know. Then you cross multiply up and down by j and you will get this answer. So there is no problem here, I guess. So let me remove this. So this is all in frequency. So you have to write it like this. So as this time it's an online exam, so there is no point in writing all this, but still you should know what this is, because in case you are going for a theory exam, then you have to write these things, otherwise instructor may deduct the marks. So keep that in mind. So this is this, and then this will again change to modulus IC, because we are in phasor format. So let me erase this here first, because this is not the question that we are looking for right now. What we are doing is we are actually calculating VTH first. VTH is this voltage, that is VAB, is the same as VTH. So here if you see, if I want to apply nodal analysis at this point, so let me call this as let me change color here.
Sir,
This is Vx. Yes. Yes.
sir, if we do source transformation, it will be easy, sir.
Yeah, depends on your choice. See, the thing is, for me, it is this approach which I am doing is easy, and this will open up, some other way of solving the question. So in case if you want to do it source transformation, you can use that one also. So until unless we are asking you to do it in a way specifically, then it's a different story. But if we are not asking you to do it in a specific way, then you can choose any options. Otherwise, you have to be stick on to what we are telling you to do. So for my case, I am trying to bring in some other concept which will be helpful for you to gain insights into how to solve using that approach, which we have also discussed last time. So I will tell you what that is. So here it is VTH. Everyone will agree with this, that this point will be VTH. This is ground. Is it okay?
Yes, sir. Yes.
So can you tell me what kind of strategy we can apply here? We have already discussed last time. Can anyone tell me this thing?
Super node.
Yes. So we will apply super node analysis here. So we will take this particular thing as a one single Gaussian surface, and we will try to see how many currents are going inside this surface and how many currents are going outside this surface. So we will add them up for applying super node concept. So here if I write like this, will you all agree that this is correct, like the one which I am writing now? Is it correct? If I write super node concept here,
Yes, sir.
right or not?
Yes, sir.
Right?
Sir, Vx by J, no?
See,
Px by
no,
Divided by J.
see, the thing is, who told me this expression here that this is right? This is J, right? Okay, yeah, you are right. This will be 1 by J, I guess, huh? Right.
yes, sir.
This will be 1 by J. So,
And that also 1 by minus 0.5 J will.
no, but this is the admittance, right? The one which we are writing over here. Let me remove this, right? And I will write it as 1 by J omega C. Then we will put the values. I think because of that confusion is happening. So this is J omega L. Everyone is okay with this?
Yes. Yes.
So let me write that first. So this is basically what? Then Vx is 1 by J omega L plus VTH. Then we have J omega C, and then we have 1 angle 0. Is it okay now?
Yes. 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 Yes.
Right?
Sir.
Right. So now you substitute the values. What will be the so if you substitute this, so you will get what? You will get minus JVX plus 2j VTH is equal to 1 angle 0, right? You will get this or not?
Yes, sir.
Yes, sir.
Okay. So once it is done, then you know that when you do a super loop, then you try to connect these points on the other side of the Gaussian surface using the inbuilt voltage supply that is there, which connects the extreme points. So I think you know that. So from our earlier analysis, so what we can do is we can write Vx minus 0.25 IC is equal to VTH. Everybody is okay with this?
Yes.
And what is IC? What is IC? Can anyone tell?
Zero.
Sorry? IC is not.
Into capacitor. 2J VTH.
Will it be or not?
Yes, sir.
Yes, yes.
Okay, so what you can do now is you can substitute this IC back here in this equation. So once you do that, it is minus 0.25 VTH j omega c is equal to VTH, and then from here you can calculate Vx as VTH times 1 plus 0.25 j omega c. You can write like this, okay? So if you solve for this, if you substitute the values properly, then VTH will come out to be 1 plus j 0.5. So this is your Vx. Quickly check whether it's right or not. So, okay, so once you have this Vx and you have this equation, right, which we have already calculated here, so you can substitute this value of VTH in this equation, which is basically nothing but this equation. So you can substitute the value of Vx from here, and then from which you will get VTH out. So if you solve this, what you will get? If you solve this, you will get VTH as 0.894 angle minus 63.43. This is the answer. Any questions here related to this particular part?
So the direct answer we have to do from the calculator. Because
Whatever it's your wish how to do it. Okay. Okay, so this is VTH. Now the second thing is RTS. So anyone has calculated that? Anyone?
sir, is it J2?
Is it? What's the answer?
J by 2?
No, it's not J by 2. Let me solve for you people, so that will also open up your view on how to do it. Normally, if you recall my earlier lecture, I told you that there are two ways of calculating R equivalent. If you remember, one is that if you have a network, then what you can do is you can apply a V test and you can go for I test, and internally whatever current sources are there, you have to open them up, and if there are ideal voltage sources, you have to short them up. So these voltage sources will be short and current sources will be open, and then you have V test, I test, and from here once you calculate, you will get R equivalent. This is the first way of doing it. Remember it or not? I told you in the earlier lectures this thing.
Yes, sir.
So this is the first way. The second way is that if you have this arbitrary network, then what you can do is you can actually pass the current I test like this, and you have a voltage V test across it, then R test is nothing but V test. If you take I test as 1 ampere, so if you take I test as 1 ampere for your analysis, then whatever voltage that you generate across these terminals will be the R equivalent or not, because you have one here, right, at the bottom. You have this current has 1 ampere, right? So that's why left is equal to right? So whatever voltage is generated across these terminals, that will become the R equivalent, because the current that you are feeding in from outside, you are actually taking as 1 ampere. Right? But in this case, what happens is we do not, substitute these, these things. So we are not doing this open and short circuit business here in this situation. Okay? So if we go by this concepts, then if I draw a V test like this and an I test like this, okay, then this current source will be open or not? This one, as I was telling you earlier, so this will be open.
Yes, sir.
Okay, so now this is very simple, right? You can do it or not, this type of circuit. So what you can do is to, this is I test, so this is I test, okay, and this IC, this already it's IC. So what will this be? What is this? This is I test minus IC, right? So if I want to write the voltage here at this point, VTH, with respect to ground, can I write like this? That is, VTH is nothing but J omega L I test minus IC minus 0.25 IC. Can I write like this or not? If you see here, is it okay? Because you have I test minus, yes.
In terms of capacitor also we can write no?
In terms of capacitor also you can write, yes. So the thing is it right or not? If I go by this loop, you can see that there is a rise in potential if I go like this. So that is basically J omega L times the current which is flowing in this circuit, which is I test minus IC, and then there is a drop in potential when you are going like this, then its value is 0.25 IC with a minus sign, and the value that you get here is VTH. So this is what it is. So are okay with this equation or not?
Yes, sir.
Okay, so now the second thing is you can write your another equation from this side. What will that be? It will be VTH is equal to IC J omega C.
Yes.
Right?
Yes, sir.
Yes, sir.
Okay, so now if you work on this and try to solve for this circuit, so what you will get as the answer is, can you solve for me? What will be the answer?
Sir, I see by J omega C होगा.
Sir, minus 2J IC.
ये ठीक है?
सर मल्टीप्लिकेशन ही आएगा.
Is it okay?
Yes, sir.
Yes, sir.
Okay. So now our job is what? You know that this VTH which I am writing over here, is it same as V test or not?
Yes, sir.
So if it is same, then we can replace this by V test, and this is also replaced by V test. So now if you substitute this IC which is not known to us into this equation in terms of V test, then your V test by I test will be the V test by I test will be your RTH.
RTA.
So if you calculate this, that value will come out to be 0.4 minus J 0.8. That is the answer. I think you can solve it, right? So this doesn't require any, any concepts. It's just the substitution. You have to substitute this IC over here, and then you can solve for I test, V test. So you will get this answer. Another simple way of doing this is just a second. Another simple way of doing it is, you can, apply, just a minute, I'll just put it here. So there are two ways of solving it. So the second way is you can, put a short circuit here. So if you put a short circuit here, then because you want to calculate this, right? If I put a short circuit here, then what will be the answer? If I,
Sir, you
CS
are
upon IC.
so no, if I put a short circuit here, what will be the answer? Can anyone tell?
Of VTH or RTH?
No, not VTH. I'm asking about the current which will flow here, ISC.
Oh. 0.25 IC.
No.
Sir, it would be 0.
Why it is
So
zero?
it will be 0. Ground, because VTH will be ground.
Ground. VTH would be ground.
And ground is ground. So
Yes,
0
sir.
correct.
VTH is ground here, and this
Yes,
point.
sir.
So what you are saying is in short circuit, no current will flow. So if you have a wire like this, what you are saying is there will be no current here. So then how come these resistances are working
Sir,
like
1 angle 0.
sorry?
1 angle 0.
Right.
1 angle 0.
Yes. So basically, if you short this, then you know that once you short this, then there will be no current flowing here, because you remember one thing: when you are shorting means you are not providing any resistance. So, for example, if a person is walking on burning fire, and another person is walking on a simple road, which one he will find more resistive? This one, right? The one where we have fire on the floor, right? So if that person walks on this thing, he will find it difficult, right? So the thing is, if that person is given a choice to move to this point, and he has two paths, one is the walking on a fire and another one is by a simple road, then which one it will take? So that person will go by road, right? So similarly here, it is basically giving you a resistance. So it's like a fire on the road. So the thing is, there will be no current flowing here across the capacitor, because all of the current which is coming from here will go actually into this path, and it will not go into this path. So if it is not going into this path, what will be the value of IC?
0.
1 angle 0.
So IC is 0. So if IC is 0,
I see 0.
so if IC is 0, what will be the status for this?
short circuit.
It will be short circuit, because it's a voltage source, right? So if I say that a voltage source is 0, that means what? That means it's a short circuit. So if it is a short circuit, then what will happen now? This current which is flowing like this, will it go this side or will it go this side? So it has two paths again for this current, going in this path and going in this path, and it knows that here again we have fire on the road, and here it is a simple road with no fire. So what it will do, it will go like this, it will go like this, it will go like this, and it will go like this. Then what will happen? All of the current will go from 1 angle 0. So now if you want to calculate RTH, is nothing but VTH divided by ISC. And what is your VTH? And VTH that you have calculated, if you write it in rectangular formats, that will be also 0.4 minus j.8. So from here you can see, by applying simple concepts, you can actually calculate the Thevenin resistance, and this one is very easy compared to the earlier one. Here you had to do some calculations, but here there was no point in doing calculation. By simple tricks you can actually get the value. So you have to select yourself what you have to do actually. So depending upon that, you have to find out the resistance, Thevenin resistance. Basically the art is which theorem, which technique to apply, so that we can get the answers at minimum cost without any efforts. So that is the main intention. Okay. So once you have this RTH, yes.
Sir, if it would have been an independent voltage source in place of dependent voltage source, would the current have still taken the same path?
Independent voltage source where?
At the place of dependent before the
Oh,
dependent
oh,
was
okay.
in place of dependent, it would have been an independent voltage source.
Okay, so what you are saying is here, if it is a plus minus like this, right?
Yes, yes.
Then what you are saying is, will that situation will happen or not? That is what your question is. That it's
Will the current will follow the same path or will it get distributed?
in this case, it will go from here as well as from here. Should go by that way, because it also has some because the value that it will be having here will be a slightly unknown. So last time, if you recall, for the voltage sources, what is the characteristics of the voltage source? Characteristics of the voltage source are what? It is this or not? This is the characteristics.
Yes, sir.
So in this case, you do not know which current it will take actually. So you have to solve it properly at that time, because we do not know how much current it will take here and how much will go in this side. Okay. But because of this dependent source, it became 0 because this IC is 0. That is the thing. Okay.
Yes.
Okay, so now since you have this resistance which is given like this, so can anyone tell me what is the components available here? Like if I say you have 0.4 minus J 0.8, can you tell me out of R, L and C which are the components available here?
R and C.
So it is R and C. Why R and C? Because if you see, we have, if you have a R and C in series, it becomes this, and then you can, cross multiply by J on up and down, you will get this expression. From this expression, what is the value of R? R is 0.4 ohms. What is the value of C here? The value of C here is 0.3125 farads. You can simply equate 1 by omega C as 0.8. As simple as that. So from here you can get R and C. So what it means now, like you have VTH given to you as,
I have a doubt.
yes.
Sir, here L can also be there, right? Because we can say that 1 by j omega c is greater than minus 1 by 1 minus j upon omega c is greater than j omega L.
Is
Overall result will be negative.
no, but the thing is, the expression that you have here, okay, you are saying an approximation is what you are saying, right? Like you are saying R plus j omega L plus 1 by j omega C, right? And then you are
Yes,
saying,
so, j omega L plus 1 j omega c will be can be minus 0.8.
this is what you are saying, right? And from here you are saying that omega L is much greater
R and
than.
C is all will come.
So this can be, one of the options. Yeah, you are right. But the thing is, this constraint has to be valid, right? So what you have to do is, actually from here, you have to actually calculate omega square has to be the 1 by LC, right? Right or not? Omega square has to be much greater than 1 by LC, then only this thing will be satisfied, right? So this constraint has to be there, then only it will be feasible, otherwise it is not. But normally, here there is no such kind of parasitic type of stuff. So one thing, see here, it is plus j, right? But here we have minus. So what you are saying is, maybe we can,
मतलब वो minus 1 by omega
ऐसा हो
c
जाएगा.
अगर बड़ा हो जाएगा.
हाँ, then only this approximation will come.
Can be greater.
Sorry?
Resultant of 1 by j omega c and j omega L can be negative, right?
Resultant means what? This resultant, this is what you are saying?
Yes, yes.
Resultant is greater than 0? Why that?
नहीं सर, यहाँ पे जैसे आपने अभी लिखा है माइनस ओमेगा एल प्लस 1 बाय ओमेगा सी, तो वो अगर ग्रेटर देन 0 होगा तो ये 0.8 आ जाएगा ना, माइनस 0.8.
Yeah, but unnecessary. Why to think in this sense? I don't know. But you are right. But the thing is, you have to approximate. You have to approximate to.
सर यहाँ पे मच ग्रेटर की जरूरत भी नहीं है, मतलब थोड़ा भी ग्रेटर होगा तो भी कंडीशन सेटिस्फाई हो जाएगी, मतलब -0.8 आ सकता है.
तो अगर यहाँ वैल्यू रखा तो व्हाट वाज द आंसर एक्चुअली? इफ ओमेगा इज गिवन टू यू एज 4, राइट? हियर इन दिस केस व्हाट इज द ओमेगा वैल्यू? इधर का ओमेगा कितना है?
सर 4
राइट?
बट सर हमें अगर ये कह रहा है मुझे, तो हमें एल और सी दो वैल्यूज अज्यूम करनी पड़ेगी ना?
नहीं, एल सी तो दे रखा है ना. यू आर गिवन दैट वैल्यूज, राइट? So maybe you have my suggestion is to check this inequality, whether this inequality is satisfying or not, to carry out this approximation which we are doing here. So basically is the other way around. 1 by omega c has to be much greater than omega L. That is then only you can write it as minus j by omega c, right or not? So what I was telling is, from this equation it will be omega square much less than 1 by LC. So if you put omega square, the value, what is the answer here? 16. And if you put 1 by LC, what is the answer? Can anyone tell this thing? What will be the answer here? 1 by LC?
0.125.
0.125.
1 by 0.
So in
1 by 0.125.
हाँ, so उसका उल्टा करेंगे कितना आ रहा है? 8. Oh.
8.
But this is not valid, right? I don't know. I think
ग्रेटर देन का
ये सही नहीं किया क्या?
साइन
The thing is actually, you are right in that sense that it can be a combination of L and C, but I don't know how to, address this in this particular thing here.
सर ओमेगा स्क्वायर ग्रेटर देन आना चाहिए.
हाँ,
आपने लेस देन लिख.
नहीं, यहाँ पर देखो ना, यहाँ माइनस लिया मैंने वापस में बाहर. I wanted to actually compare this with this expression here. So that's why I taken minus. So if I take minus here, then this will be 1 by omega c minus omega L or not?
सर आपने एल और सी की वैल्यू सर्किट में से ली, वो तो हमें फाइंड करनी है ना अभी.
नहीं, फाइंड क्यों करनी है? एल और सी की वैल्यू तो हमें गिवन है ना.
सर इक्विवेलेंट अलग आएगी ना लास्ट में? इक्विवेलेंट में अलग आनी चाहिए.
विच इक्विवेलेंट? दिस इक्विवेलेंट?
सर
नहीं,
सर ये अलग है ना, ये एल और सी अलग. क्वेश्चन मार्क.
जस्ट
हाँ सर, जो आरटीएच में निकाला ना, वो हमने इक्विवेलेंट इक्वेशन निकाला ना, तो उसमें एल और सी की वैल्यू अलग हो जाएगी.
हाँ, उसमें तो अलग हो जाएगा, यहाँ पर तो अलग हो जाएगा. दैट इज अ डिफरेंट स्टोरी. बट
मैं यही कह रहा था कि अगर हम जे की सीधा अगर माइनस आ रहा है तो सी मान लेंगे और प्लस आ रहा है तो एल मान लेंगे, बट अगर उसमें दो वैल्यूज अज्यूम करना हुआ तो वो तो लंबा हो जाएगा कि एल का भी अज्यूम कर रहे हैं और सी का.
वो वाला एक्चुअली में नहीं. बट योर क्वेश्चन वाज राइट दैट it can have a combination of L and C also inside, because
कॉम्बिनेशन हो सकता है, बट वो सोचना ज्यादा लंबा हो सकता है.
हाँ, वो लंबा है. Right. The simplistic way is to just assume that you have R and C or R and L. Okay. So yes.
Can you give me some of the source transformation once, please?
In this one?
Yes, sir. In initial one.
एक मिनट है.
With dependent.
ये वाले में सोर्स ट्रांसफॉर्मेशन कैसे करोगे बताओ तुम? How will you do that?
Sir, that current source will be converted into voltage source.
Okay, so what you are saying is you have to convert this into a voltage source. Okay, so इसमें क्या है? इसमें तो you can do it, right? इसमें एक यहाँ पर j omega L हो जाएगा, and then you will have a voltage source with the value 1 angle 0 that, and then j omega L. So that value you can write a KVL, KCL and all that type of stuff. You can do that, right?
Yes, sir, I have done, but sir, in that a constant term is remaining, like j equals 4t.
Means 1 angle 0 is remaining and V test equals to 1 angle 0 plus I test, like that way it's coming.
You can solve this and email it to me rather than, I will not go into that here right now. Okay? Because I have to solve some more questions also. Okay?
Explain that how we find VTH.
But the important thing is, it's easy, right? You can write j omega L and then you have a voltage source with the value of j omega L times 1 angle 0. So simple KVL will work out here. So it will not be a problem. Okay, so so you have this R given as you have this R value given as 0.4 and C value is 0.3125 farad. So effectively, if you want to represent, it will be like this. Here VTH will be 0.894 angle minus 63.43, which is the VTH which you had calculated earlier. And then you have 0.4 and this is the capacitor of value 0.3125 farads. And now the second part of the question is that if you have a load resistor connected here and the value of that load resistor is what was the value? 1.2. So now can you calculate the voltage across this easily or not? So it's just a voltage divider only, right? Can you do it or not? It's easy, right?
Yes.
So it's just a voltage divider. So once you do that, the VRT, the voltage VRT will be 0.6 minus 36.87 degrees. And if I want to write in terms of the time domain, how will I write it? I will write it by operating real part on this. 0.6 minus 36.87 degrees. So if I operate real part on this polar format, I will get 0.6 cos, what is the omega here? 4, right? 4t minus 36.87 degrees. So this is the answer for the voltage across the resistor. Any questions here related to this calculation? I guess you can do that right now. It's very easy, right? Voltage division only. Okay, so let's move to some more questions. Yes.
How did we get that? How did we transform L and C and change the value R equals to 0.4 and C equals to...
This is basically comparison only, right? You have this RTH available here, right? And you know mathematically if you have R and C in series, you will write it like this. And from here you can cross multiply with J on top and bottom. So you will get something like this. From here, if you want to compare this equation with this equation, your R will come out to be 0.4 ohms. And C, if you want to compare the imaginary part, then it is 1 by omega C equal to 0.8. And omega you know already. So from here you can get C. Okay. Okay, so now let's move to another question. If you have something like this, let us say 20 cos 250t, you have 8 ohms, 36 millihenry this side, and then you have 0.25 millifarads, and this is VAT. You have 1.2 cos 250t plus 45 degrees, 80 millihenry, and then you have this 4 VAT. So if I want to calculate the value of VAT now in this circuit, I'll give you 5 minutes to solve this. Calculate VAT. Anyone has solved it? So the thing is, you have to actually practice, because if you do not do it, it will be a very tough question then. So which approach you are taking for doing it? Which theorem you are trying to solve for? Using which theorem you are doing it?
Sir, we can do by nodal analysis.
Yes, yes. So I think nodal analysis will be the perfect choice here, because you can see the way the way this diagram is looking. It's better to go for nodal analysis here. So if I write it in phasor format, how will I write it? 20. What I will write for this? Anyone?
20 angle 0.
So it will be 20 angle 0. This remains the same. What about the 36 millihenry? What will this be?
9J.
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 So let's keep this as j omega L for a time being, because otherwise it will create confusion. So this is, I am putting it as 1 by j omega C, and this VAT will be now bold V. Then we have here j omega L. How about this current source? How will you write it? What will be the
1.2 angle 45.
right?
1.2
Right. 1.2 angle 45 degrees. And this is now right. So this is L2, this is L1, right? And this is now bold V, A rather here. So if I want to write nodal analysis, let me know if I am writing it wrong or something like that, and if you are comfortable with this. Are you okay with this?
1 upon j omega L2.
J omega L2.
1 upon j omega L2 आएगा.
हाँ, right, good. Yeah. So everyone is okay with this equation? I am writing nodal analysis at this point. So if you are not, then I think then you have to practice a lot.
So for a minute, can you show the circuit?
Circuit?
Yeah, the original.
Original, okay.
Okay, done. Done.
Yes, sir, it is okay.
Okay, fine. So are you comfortable? Anyone having any problem can ask me now. So I am assuming that all of you are comfortable with this if nobody is asking me. Okay, so this is simple nodal analysis, and what we are doing is we are actually assuming the currents flowing in all branches outside. So if you do this thing, you will get this answer. Okay, so now once you solve for this, it's very easy, right? Just so now what you have to do, you have to only calculate VA, and there is no unknown here. Everything is known to you. So once you do that, your VA will come out to be 0.2636 angle minus 106.41 degrees. And if you want to calculate the time domain of it, it will be, you apply real part on this, real operation on this. So once you do that, you will get 0.2636 cos, then you will have 250t minus 106.41 degrees. So the takeaway point, if you again see here, is even these voltages which you are calculating are having the same frequency as we were discussing last time. So here all these questions which you will be getting in the exams will have the same frequency. And if you want to calculate the currents, they will also operate on the same frequency, but only the phases will change for different branches, and similarly for voltages. Okay, so right now I think I wanted to solve 3-4 more problems. Let me.
Sir, one thing, sir.
Yes.
Sir, while calculating VA, we will get 20 angle 0 as 20 cos 250.
What you are saying, I didn't get you actually.
Sir, while calculating VA, what can we write out 20 angle 0?
20 angle 0? Okay, this one?
Like we will
No.
In rectangular.
See, the thing is, you can convert this into polar format, right? You can convert it into Cartesian coordinates, and then, or you can convert this one into polar and divide the two and get the answer. Is it?
okay.
So you know that when we have these things in fraction, so polar is the best way of doing it. So you convert this into polar format first, divide this, get the polar representation. So it's a mix of polar and Cartesian. So you have to see, like, if you are adding, it's better to do it in Cartesian. If you are having a division, it's better to do it in polar. And then once you finally add the things up, you will finally be comfortable in doing it in Cartesian coordinates. So if you look for the Cartesian version of this, it is 0.4706 plus j 11.76, no, 0.1176, not 11.76. So once you convert this, you will get this answer. Okay. Okay. So let us solve one more question. So if you have, 10 cos. Okay, I think right now what's the time? It's 11:30 or what?
11:24.
Okay. I think we will not be able to solve this question during that time. So maybe in the next class we will continue solving some of more questions, and then we will finish off with the AC analysis, and then we will move to some other topic. Okay. So you still have, I think.
You can give me.
Huh? Okay. Let me give it to you then.
Just
Okay. So let us say you have with this question 10 cos 10d. Then you have 10 ohms. So what you have to do is you have to find IT here, and this is the question. So any questions here related to this? Any problems? Or if I have missed something, you let me know.
no. Previous question, how can we find current?
So that is what you have to solve actually.
No. In previous question.
What do you want to calculate here? Current.
Current passing through capacitor.
So that is easy, right? So once you have this voltage VA, you can divide by 1 by j omega c to get the current passing through the capacitor. Okay. And similarly, that is the advantage of nodal. So once you have this, you can take this, subtract from here, divide by j omega L2, you will get the current flowing here. Okay. So all these are, that's why that's an advantage of doing nodal. Okay, so this is the question. Solve it. Yes.
Sir, here we can directly write a impedance like 10 millifarad and 10 ohm in parallel, like by converting in this and then implementing math.
I didn't get you what you are saying.
Sir, we will convert 10 millifarad into that phasor form, and then we can do
Yes.
parallel like 10 ohm and that what the value will be.
Yeah, yeah. You can do any trick, whatever you want. You can either take combination of this, or take source on transformations, use nodal analysis, whatever whatever suits you. Answer will come out to be the same. So try to do it through different ways. Try to solve it through nodal analysis. Try to solve it through basically your source transformation, and try to solve it through whatever you want actually. So you can do it through Thevenin also, if you want to, because if I want to ask, if I ask you how to solve it through Thevenin, how will you do it? Can you tell me? Let us say I want this circuit. I want.
Resistor.
You will do what?
5 ohm resistor. Remove 5 ohm resistor.
Why 5 ohm? Why 5 ohm resistance will be removed? See, why we are interested in IT, right? We are interested in IT, right?
10 cos 10 we will remove it and then find
Yes. So,
the value.
so you have to remove 10 ohm resistance first, and find the VTH and RTH from here. And once you find the VTH RTH from these across these two terminals, you will get something out. Like you will have a VTH like this across. Let us say this is A, this is B. So you will find a VTH across VAB, then you will find the RTH across AB, and then you will do the 10 ohm resistance back onto the circuit, and then you will calculate the current across this. Getting my point?
Yes, sir.
So you can do like these type of questions through Thevenin also. Try to see how can we solve it, which one is easy, which one is not. Try to see. Okay?
I have one doubt in VTH first.
Sorry, for VTH in what case?
Sir, first case, and I have one doubt.
First case means what? This question or something else?
Sir, starting question of the class, like.
Starting, okay. Okay, yes.
Yes, sir. It's at VTH part, like how we calculated at final, like the steps you can show once again.
No, I cannot show you now because it's already, time is over, and I cannot repeat all these things because this is the first question and I asked you.
Sir, I just want to see that, please. Like, just see. Oh, sir, one PDF down, like this down.
I will pass it to you, the lecture notes. You can see it from there. Okay.
Sir, can we leave if we don't have doubt?
Can you speak again what you are saying?
Can we leave if we don't
Yes,
have
yes. I think I'm also closing the class now, so it's already 11:30. So.
Sir, please send the recording of
Yeah. I'll do that. Yeah, I'll do that. Okay. Okay. Bye.
Thank you.
Thank you.